Welcome to this video lecture series on antenna and wave propagation. In this video lecture, we'll discuss the slot antenna. We'll start with the basic definition of slot antenna, then we'll see the features of slot antenna, then we'll see the comparison of slot antenna with the dipole antenna, and then we'll see the feed methods of the slot antenna, and at last we'll see the uses of slot antenna. So for your reference, I have this structure. So if I am considering this structure to be my metallic surface, so I am considering this rectangular structure to be a metallic surface. So if I have a slot of rectangular shape, so now this slot could be of any shape. Now for this structure I have the slot of rectangular shape. So if I have the slot of rectangular shape, this metallic structure would act like a slot antenna. So from the slot on this metallic surface, I would get intense radiations. So these radiations are acting like a transmitting antenna. So now this slot antenna is acting like a transmitting antenna. We will see various other features of the slot antenna as well. So now I hope you can understand how the slot antenna looks like. So now coming to the definition of slot antenna. So what is a slot antenna? So slot antenna is a radiating slot in the metallic sheet or waveguide which is fed with the help of transmitting coaxial cable or waveguide. So if I am considering this to be my metallic structure, so if there is a slot of length lambda by 2, now here I am taking the length to be lambda by 2 and this is a horizontal slot because the length is greater than the width. So increased length, that is lambda by 2 length, is more in horizontal direction, so it is a horizontal slot. So this is a 2-wire coaxial cable. So this antenna is getting its energy from this 2-wire coaxial cable which is fitted on this slot. So now the width of the slot is represented by W, the length is lambda by 2 and these arrow represents the electric field. So now I can say my slot antenna is acting like a radiating device. So I can say the slot antenna is more of a transmitter type of antenna. So it is acting like a radiating device. So now we will see the features of the slot antenna. So the first feature, as I mentioned here, that the length is very much as compared to the width of the slot. So if I am taking my length to be lambda by 2, width should be very less than the length which is lambda by 2. In this structure, this length is lambda by 2 and this width should be very much less than lambda by 2. So this length and width should be very small. So this structure should be very small. For your reference, I made a larger structure, but actually the slot antenna is very small. As you can imagine, the lambda is very small, so the lambda by 2 value is also very small. So the overall structure is very small. So now we can say that the first feature is that length is equal to lambda by 2 and width is very much less than length for slot. The length and width of the metallic structure could be larger than this value. The second feature is there could be array of slots present on the metallic surface to increase the directivity of the radiating electric. You can see this from this figure. So in this figure, an array of various slots is present and which is increasing the directivity of radiating electric field. The third feature is the horizontal slot provides vertical polarization and vice versa. Means the horizontal slot provides vertical polarization and vertical slot provides horizontal polarization. The fourth feature is So the large electric field supplied at the slot helps in providing intense radiation around the slot. So as I said, it is acting more like a radiating device, and the metal plate around the slot is helping to provide more radiations. So the last feature is so it resembles like a dipole antenna in various features like radiation pattern, but the polarization achieved by the slot antenna and the dipole antenna are complementary in nature. So if horizontal slot is providing me vertical polarization, then horizontal dipole antenna is providing me horizontal polarization. That is, horizontal dipole antenna provides horizontal polarization and vice versa. So if I have a slot antenna and if I have a dipole antenna, I can say these two are complementary. I can prove this with the help of Babinet's principle. So Babinet's principle is actually applicable on the optics, that is ray optics, but it is applicable on EM waves as well. So I would understand the Babinet's principle with the help of this structure. So I said this structure was acting like my slot antenna. So this was the metallic structure and this was the slot. So this was the piece which was cutted down from this structure. So this is the complementary piece to this structure. So if I have this structure, the only complementary piece to this structure would be this structure. So if I pass the light rays from this structure, I would get the light to be like this, passing through this. So now this and this are complementary to each other. So now the product of this structure and this structure according to the Babinet principle is given by eta square by 4. So now I can see the comparison of ZS and ZD. ZS represents the impedance of slot antenna. ZD represents the impedance of complementary dipole antenna. So if this is my slot antenna, this is the slot of lambda by 2 length, and I am feeding it at the center, that is lambda by 4 from this side and lambda by 4 from this side. So similarly I can have a dipole antenna. So the cutted down portion is in the form of this dipole antenna and it is fed by some source with the lambda by 4 length from here and lambda by 4 length from here. So its complementary form is the dipole antenna, and ZD represents the impedance of dipole antenna, ZS represents the impedance of slot antenna. So according to the Babinet's principle, as I said, ZS into ZD is equal to eta square upon 4. I know that ZD is nearly equal to 73 plus 42.5 J ohm. Now putting the value of ZD and eta, I know eta is equal to so eta square upon 4 would be equal to, so now taking this value this side, now multiplying and dividing by 73 minus 42.5 J. So the final ZS came out to be 363 minus J211 ohm. So now this is how I can find out the relation between ZS and ZD. Now for any value of ZD I can find out ZS. So now for any complementary value of ZD, which could be of any length. So now for any value of ZD, that is for any length of this dipole antenna, firstly I took the length to be lambda by 2, so ZD was this. So now if I change the length, ZD would change and similarly ZS would change. So I can find out the impedance of slot antenna for any impedance of dipole antenna. For any impedance of dipole antenna, which means for any length of dipole antenna. So now we'll switch to the feed methods of slot antenna. So now I have two types of feed methods of the slot antenna. First is center feed and second is off center feed. So as the name is suggesting, in center feed method, my coaxial cable or the two-wire transmitting cable or the waveguide. So this could be anything. This could be. So now for center feed method, my feed should be at the center of the slot. So if this is my slot is of lambda by 2 length. So the feed is supplied at the lambda by 4 length from this end. Similarly, lambda by 4 length from this end. So now second is off center feed method. Again, this could be anything. This could be waveguide or this could be two-wire coaxial cable. So now as the name is suggesting, it is off center. So means it is not at the center. So the feed is applied at, if this is lambda by 2, it is applied at lambda by 20 distance from one center. So it is applied at lambda by 20 distance from one center, and similarly from here it would be 19 lambda upon 20. So I have two types of feed method, which is center feed and off center feed, and in center feed I have three cases, which is the feed should be coaxial cable or it could be waveguide or it could be two-wire transmission line. Similarly, in off center I could have waveguide, coaxial cable or two-wire transmission line. So when I have center feed method, it is actually matched with a coaxial cable of around 500 ohm impedance. Whereas in the off center feed method, the slot is matched with the coaxial cable of around 50 ohm impedance. So now this is how I conclude my discussion about the slot antenna. So I hope you understood the various things which I discussed in this video. I hope you like this video, subscribe my channel and stay tuned for the further videos. Thank you.